Good morning to one and all. Mm, I welcome you all for the today's morning session. I'm Professor Raju Patil from Mechanical Department, Angli Engineering College, Belagavi. So today we'll be discussing in energy engineering subject. We'll be discussing fuels for steam generation. Okay. So steam power plant uses most probably fossil fuels to generate steam. Okay, the fuel may be in different forms such as solid, liquid, pulverized, or gases, etc. Okay, so then selection of type of fuel depends upon the availability of fuels and economic conditions. Okay, solid fuels. Coal is the most abundantly available fossil fuel. Coal is highly carbonous matter that has been formed from the prehistoric vegetable deposits which have been decomposed and solidified under combined effect of great pressure. Okay, contact takes up this coal takes up lot of space. Also, it's heavy and dirt to handle. The different forms of coals are peat, lignite, bituminous coal, and anthracite coal. Okay, the chemical substances in the coal are carbon 50 to 95% range, hydrogen 1 to 5.5 range, 5.5% range, nitrogen 0.5 to 7%, oxygen 2 to 40%, and sulfur 0.5 to 3%. So liquid fuels, all types of liquid fuels used are derived from crude petroleum and its byproducts. Okay, the petroleum or crude oil consists of 80 to 85% of this, and 10 to 15% of hydrogen, 80 to 85% of carbon, 10 to 15% of hydrogen, and varying percentage of sulfur, nitrogen, oxygen, and compounds of vanadium. The fractions from light oil to heavy oil are naphtha gasoline, kerosene, diesel, and finally heavy fuel oil. The heavy fuel oil is used for generation of steam. Okay. Advantages of liquid fuel: higher calorific value than solid fuels, less ash formation as compared to solid fuels. They can be easily stored in tanks and require less space, hence handling becomes very easy, okay, compared to solid fuels. Combustion can be controlled easily, easy to transport through pipes. Gaseous fuels, for the generation of steam in gas fired thermal plants, either natural gas or manufactured gaseous fuels are used. However, manufactured gases are costlier than the natural gas. Okay. Next, we'll be discussing about the here. You all can see equipment for burning coal. Equipment. What are the equipment for burning coal? Solid fuel or lump farm. They are in that firing, mechanical stroke firing, pulverized fuel or powdered farm. In that unit system and bin system. As I said in the previous class, unit system and bin system we have discussed. So we can go ahead with mechanical stoker firing. Even though it is costlier, generally they are used to feed the solid fuels in small and medium size power plants because of the following reasons. Combustion is more efficient. Fuel handling is automatic and combustion control is easier. Faster response to load fluctuations. Okay, low quality fuels can be successfully burnt, suitable for small to high capacity plants. Principle of mechanical stroke firing. Here there are two stroke firings, overfeed and underfeed. First of all, we'll discuss with overfeed stokers. An overfeed fuel feed stoker receives fresh coal, that is fresh coal in the sense green coal, on its top surface. You all can see in the sketch in this figure, on the top. Okay, on the top it is there. Huh? You all can see on the top surface what is the green coal, or it receives a fresh coal. The ignition takes place between the green coal and incandescent coke. It is characterized by the following zones from top to bottom: a layer of fresh green coal, a layer of coal losing moisture, a layer of coal losing volatile matter, that is distillation zone, a layer of incandescent coke where fixed carbon is consumed. So you all can see the primary air. You all can see in the figure the zones are fixed here. Okay, first zone, second that is green, and third one is incandescent, and below that incandescent coal is a incandescent coal. Below that you can see the ash, and before uh, at the bottom you all can see gate, and this is a primary air enter from this through the gates. Okay, this is about overfeed. The air then passes through the distillation zone where volatile matter is added, and then through the drying zone where moisture is picked up from green coal and finally emerge above the bed. Okay, for the complete combustion of combustible gases, secondary air is fed to the furnace to supply need oxygen. Okay, you all can see the secondary air above near the flame. The flame is shown. Okay, and underfeed stoker, these are the underfeed stokers. You all can see here same process, that is a flame over there with secondary air, and ash is below that, and below that is incandescent coke, and below that is green coal. Huh? So you all can see this. You can see underfeeding. Okay, what is underfeeding? In underfeed stoker, coal is fed from below the gate by a screw conveyor. Okay, by a screw conveyor, and the primary air under pressure also moves from the bottom through the holes in the grate. Okay, this stoker has the layer of ash, incandescent coke bed, and raw coal in the reverse direction as compared to that of the overfeed stoker. You can observe, no? You can see the difference between the overfeed stoker and underfeed stoker. Yeah, the reverse method is followed here compared to overfeed. Okay, in operation, the primary air entering from the bottom through the grate holes diffuses through spaces in the raw or green coal, picking up the moisture, and then passes through the distillation zone where volatile matter is added. When the gas stream passes next through the incandescent coke region, air reacts with carbon in the coke to form carbon dioxide. Air reacts to with carbon form carbon dioxide, and the moisture in the air reacts to release carbon dioxide, carbon monoxide, and hydrogen. Okay, while these gases pass over the ash bed and secondary air is supplied for the complete combustion. This method is most suitable for semi-bituminous and bituminous coals which have high volatile matter. You all can see the flame over here. Huh? At the top surface you all can see the flame with the secondary air. Okay, so next you all be seeing here the types of stokers. Different types of stokers: overfeed stoker and underfeed stoker. In overfeed stokers, conveyor stoker, chain gate stoker, traveling gate stoker, and that is B1, that is spreader stoker. And in underfeed stokers, under that comes single retort stoker, multi retort stoker. So first of all, we'll discuss with chain and traveling gate stoker. A chain gate stoker consists of an endless chain. Okay, endless chain which forms the support for the fuel bed. The chain is made of cast iron links connected by pins. The chain is held over two sprockets. Two sprockets you all can see in the figure. Two sprockets at the front sprocket, and one more is another sprocket. There are two sprockets over here. Okay, huh? You all can see the two sprockets in this. Okay, as shown in figure, and travels from one end of the furnace to the other end. The sprocket at the front end is driven by the electric motor. The coal is fed at the front end and through a hopper which is carried by the chain to the other end, hence into the furnace. The air necessary for the combustion of fuel is supplied through the air inlets below the travelling gate. The secondary air is supplied through the openings in the top roof as shown in figure. The rate of the fuel supplied to the grate and hence the heat to the boiler can be controlled by two means. The first means is to control the depth of the coal bed depth of the coal bed on the gate by controlling the feed to the hopper, and in the second method the speed of the chain grate can be adjusted to meet the boiler operation requirements. The chain grate stokers are widely used for burning non-caking such as does not form solid mass while burning, free burning, volatile and high ash contents coals. You all can see the figure here. Front sprocket, and it is connected to other end, that okay, where hopper is there. Okay, and this front sprocket is driven with the speed of the motor. Okay, it is driven with the help of motor. Okay, and you all can see the rear ignition arc here. You all can see where ash pits are collected to ash pit. Whatever the ash is collected, it will be collected at this end below. You all can see. Advantages of chain stokers: simple in construction, low initial and maintenance cost, self-cleaning stoker, combustion control is simple by control of feed or chain speed along with the air supply. Just listen once more. The third advantage, that is the fourth advantage, combustion control is simple. Why? Because control of feed with the help of chain speed along with the air supply. Its combustion efficiency is high. Okay. Disadvantages: it is suitable only for small capacity plants. Coal losses are high as the unburnt coal may also move with ash. If caking coal is used, ash clinker problems may arise. Okay. Next, you all can see this spreader or sprinkler stoker. In this type, you all can see by viewing the figure itself, it indicates that coal from the hopper is fed. You all can see the coal hopper here. Coal from the hopper is fed onto the rotating feeder. Rotating feeder, you all can see the feeder which rotates a drum with a short blades on its surface, which in turn feeds to the uh, coal to a rotating spreader or sprinkler. You all can see sprinkler. Example, sprinkler you might have seen in fields, for water sprinkler which sprinkles the water surroundings, or distributor you can see. Below which the projects the coal particles in a continuous stream on the grate holding an ignited fuel bed. The finer particles burn in suspension and coarser particles are consumed on the grate. Okay. So the grate consists of yeah, carbon, cast iron bars, links underneath. Okay, links underneath there, links are there. The grate connects all bars to a lever. Moving the lever back and forth makes the bars rock about their pivots, which makes the ash fall through the ash pit below. Okay. Hmm? Understood. The advantages of spread stokers: a wide variety of coal can be burnt, varying from lignite to bituminous coal. Having high ash content can be burnt. The clinkering problems are reduced due to spreading action. The system provides thin and even fixed bed fire bed, you can say, and results in high rate of combustion. Single retort stoker: the principle of construction of single retort stoker, you all can see. In the stoker, the fuel is burnt on a retort. The fuel is placed in a large hopper on the front end of the furnace, and then it is further fed to the reciprocating ram into the bottom of horizontal trough. With the feeding from the bottom, gradually burning coal rises up above the green coal. An incandescent coke layer is formed, and above which the ash layer is formed. With the continuous feeding of green coal, the ash level rises. The ash and the clinkers are collected on the ash plate and provided with a dumping arrangement. You all can see here in the figure. There is a retort. Okay, and here is the hopper where we fed it. And tires can see here, and you can see the multi spread or spread stokers, and next will be multi retort stokers. Multi retort stokers, it contains series of retorts with tires. Okay, and pushers. It also consists of fuel hopper. You can see the fuel hopper also here. Fuel hopper. Okay. Fuel hopper and coal pusher at the hopper end. At the hopper end, you all can see both fuel hopper and coal pusher, which pushes the coal. The coal fed through the hopper is pushed by the main pusher driven by a ram. Okay, driven by the ram. The distributing pushers in the retorts push the coal and distribute it to all retorts. The movement of the fuel fed by the pushers helps in minimizing the clinker formation. The primary air enters the wind box. Primary air enters into the wind box below the retorts and flows through the retorts as the as the air damper is provided. Okay, air damper, you all can see the air damper is provided at the air at inlet and the wind box to control the airflow to the furnace. So next class we'll be discussing about the pulverized. Okay, pulverized fuel burning. Next class we'll discuss. So today we stop with this session. So if you have any doubts, you can contact me. Thank you for the today's session.